Hello. Let's go ahead and take a look at capital budgeting. So let me go ahead and pull up capital budgeting here. Now, capital budgeting is basically a great tool to use to make business decisions. And there's three different methods we're going to look at in here. We're going to look at payback, we're going to look at net present value, and we're going to look at internal rate of return. Now, all of them involve the use of cash flows, which cash flows are deemed to be better to judge investment perform or are basically financial performance in the case of making business decisions. So all of them are going to use cash flows. Um, Basically, net present value and internal rate of return use the time value of money. So they actually use the time value of money. Now, payback does not. Now, let's start with payback. Now, payback is basically, if you want to talk about a formula, it's basically just if you have even cash flows over the life of an asset, it would basically just be the amount invested divided by the cash flows. And the cash flows are typically annual. Typically, we're looking at this in terms of annual cash flows. So let's say that we had amount invested of $50,000. So say we purchased equipment for $50,000. And let's say that this equipment was going to give us cash flows of 15,000 per year. So, how long would it take that equipment to basically give us back our initial investment? So, what payback is looking at is how long does it take us for us to make back our initial investment? How long does it take us to make back our initial investment? So, in this case right here, we would take the amount invested divided by the annual cash flows, and we would get basically 3.33 years. So it'd take 3.33 years to make back our initial investment. So payback, amount invested divided by cash flows coming in. How long does it take to make back your initial investment? Now, if now that's cash, now that is looking at payback with even cash flows every year. But what if you had uneven cash flows? Then this is kind of an example of how you do payback with uneven cash flows. Let's say that our amount invested again was $50,000. And this say year one, the investment brought in $20,000. So we would take our amount invested, uh, subtract out that first year cash flow, and we've got 30,000 then yet to cover. Um, let's say in year two, it brought in 15,000 in cash flows. So 30 minus the 15, we've got 15 still yet to cover. And in the third year, we bring in 25,000 in cash. So we have a positive, basically 15,000 in cash after 3 years. So somewhere between years 2 and 3, payback was achieved. Now, if we want to find out exactly when it was achieved, then we would start with 2 years because it was somewhere between years 2 and 3. And what we would do is we would divide how much came in year three by what was left to cover. And in this case, we get zero point 0.6. And so we add them together, and it would take us 2.6 years in this case to achieve payback based on these numbers. So 2.6 years to achieve payback based on this information. Now, payback is a really good method because it's very easy to use. It's very easy to understand. And companies that use payback, um, a lot of times will set a goal. Like they'll say, like, we won't accept a payback under 4 years. And so they'll evaluate investments. And if they don't give them a payback in the time period that they've set, then they won't accept the investment. Um, Payback is easy to use and it's valuable. It is a valuable way to look at something because today in business, things can change very quickly. So there is some value to examining how quickly are we going to make back that initial investment. Probably the one downside to the um, probably the one downside to the statement of cash flow or to the excuse me payback is that payback does not use the time value of money, which does factor into the two other methods we're going to look at, net present value and internal rate of return. So let's look at those. So net present value, also known as NPV. Um, let's say, for instance, we had some equipment and it cost us $50,000. and it's going to give us annual cash flows of 15,000 per year. Again, with net present value, like all of the methods we're looking at here, it uses cash flows. And then let's say we had a discount rate of 12%. What a discount rate is every company has to determine their own discount rate. And a discount rate is really, but without better words, what is the minimum required rate of return on an investment that a company is willing to accept? So for one company, 10% might be great. Another 12%, like in this example, another 15, another 20, another 6. Every company has to come up with what's kind of our required rate of return. Sometimes you'll see this as discount rate. Sometimes you'll see this even as cost of capital. Sometimes you'll see this as hurdle rate. There are different terms. I'm going to use discount rate here, but you could see it from a terminology standpoint in other ways. And then the useful life, of course, is just simply how long are we going to use this equipment in the business? So if we want to do this in Excel, which Excel is you're going to find is the best way to do net present value or the next method, internal rate of return. We're going to start off with, we're going to compare the initial investment, which was 50,000, to the present value of the future cash flows. So let's look at that. The way that we're going to do this in Excel is you want to go up here to the insert function. You want to click on it. And right here for category, you're going to go to financial. And then you're going to go down to NPV, which is right here, net present value. And you want to click on it. The rate, this is the discount rate. So I'm going to put in 0.12%. And then I'm going to put in all the values. So in this case right here, this piece of equipment is going to give us 15,000 in year 1, 15,000 in year 2, 15,000 in year 3, 15,000 in year 4, and 15,000 in year 5. And I click OK. And the present value of the future cash flows is $54,071.64. Now, if the present value of the future cash flows is larger than the initial investment, then you have positive net present value and you can accept the investment. So in this case right here, if I were to take the sum of these two, be a positive $4,071.64. So this is positive. And if you have positive net present value, that means that, again, the present value of the future cash flows is greater than the initial investment, then you can accept the investment. This is a good investment. And basically what positive net present value tells you is that this investment is generating a return greater than the discount rate. So in this case, this investment is generating a return greater than 12%, greater than the 12% discount rate we said. Now, let's look at one more example here. Again, we've got equipment, 50,000, annual cash flows, 15 per year. The discount rate is 20%. Now, I've raised the discount rate up in this case. And one thing to think about here is the higher the discount rate, the harder it's going to be to find acceptable investments that will produce a return greater than that discount rate. And then the useful life, again, 5 years. Now, one thing I did want to add in here, I wanted to show you something a little differently here too, is sometimes a problem will have salvage value involved. And if you remember back from depreciation, salvage value is simply what an asset is worth at the end of its useful life. So in this case, we buy the equipment for 50,000 and we use it for 5 years and it's worth $5,000. Sometimes an asset will have no salvage value, kind of like the first example we looked at, but this one it has 5,000. So let's work this problem out here. So again, we're going to compare the initial investment, which is 50,000, with the present value of the future cash flows. So again, we go up here to insert and we can go to, we're on financial right now. And so we're going to go down to NPV for net present value. And we're going to put in the rate this time. So we're going to put in what, 20% right here. Let's do that right. 20%. And then we're going to put in the value every year. So year 1, 15,000. Year 2, 15,000. Year 3, 15,000. Year 4, 15,000. And year 5. Now in year 5, we're going to get another 15,000, but we're also going to get the 5,000 from the salvage value. So I am going to put 20 in here for year 5 because we have to include the salvage value. And notice that in this case, the present value future cash flows is 46,868.57. So if we sum the two together, we have a negative $3,131.43. So this amount would be negative, and negative net present value, you should reject the investment. And why you should reject the investment is, again, this investment is not giving you your discount rate or your required rate of return. Because if your discount rate is 20%, then you feel like you need to make at least 20% on any investments that you accept. So in this case, since we had negative net present value, this investment is not giving you a 20% return. And so you should reject it. Now, and again, like I said earlier, the higher the discount rate that you set, the less likely or the harder it is to find acceptable projects or acceptable investments that are going to give you that higher rate. So let's look at one more. Let's look at internal rate of return. An internal rate of return also uses the time value of money, just like net present value did. An internal rate of return, let's look at the same information. So we've got equipment that has cost of 50,000, annual cash flows of 15,000, discount rate of 12%, and useful life of 5 years. Now, if you're doing internal rate of return in Excel, you want to set it up just like this. And basically what I did was I put the initial investment, again, 50,000, and I put it as a negative number, that this is basically cash we're paying out when we make this investment. And then I put all of the cash flows that are going to be coming in from this investment. Notice 15,000 for each of the 5 years. You want to set it up this way when you're doing internal rate of return in Excel. Now, so let's find out what the internal rate of return is. So I would go up here to the insert function. And again, I'm on financial. And this time I'm going to go down to IRR for internal rate of return. And I click on it, hit OK. And I'm basically just going to click this thing here. And I'm going to highlight that entire area that I just put in there. Hit enter. And then OK. And it's going to give you your internal rate of return here. And I can take it over a couple of places, and you see that it's 15.24%. Now, when you're doing internal rate of return, what your goal is you want to compare the internal rate of return that you computed with the discount rate. And since the internal rate of return is higher than the discount rate, you can accept the investment. So if the internal rate of return is higher than the discount rate, in this case it is, the internal rate of return was 15.24%, the discount rate was 12, you can accept the investment. Now, if the internal rate of return is less than the discount rate, if the internal rate of return was 20%, like the other example we looked at, then we would reject the investment because this investment would not be giving them a 20% ROI, or excuse me, a 20% discount rate, excuse me. Okay, so that is capital budgeting. Capital budgeting is very useful for business decisions. And a lot of times, I will say this, companies will sometimes use two of these methods. It's very common for a company to use payback with one of these methods because all of them add something to the decision. Payback looks at how quickly you get your initial return back, while net present value, internal rate of return, use the time value of money, and evaluate your investment from that standpoint. So a lot of times the company will use payback and net present value, or payback and internal rate of return. They'll say that we will not accept an investment unless it gives us a payback of less than 5 years, and unless it has positive net present value, or unless it has a internal rate of return higher than our discount rate. Then basically that's how they judge the performance of an investment, and that is how they make business decisions.